Welcome, geometry student, to the homework up video, page 549. Let's go ahead and get started with numbers 6, 7, and 8. For numbers 6, 7, and 8, the directions say to find the area. Alright, so notice we have a quadrilateral here. 4 sides, 1, 2, 3, 4, in which the diagonals are perpendicular. So anytime a quadrilateral has perpendicular diagonals, we're going to take 1/2 times the two diagonals. Well, if the length from here to here is 15, then this diagonal is also 15. And the length if from here to here is 20, then this diagonal is 20. So I have 1/2 times one diagonal, which is 15, times another diagonal, which is 20. If you multiply those together, you will get 150 square units. Okay? 150 square units. Moving on to number 7. Okay, now, first of all, students, I'd like to point out to you that even though you don't know that the two diagonals are perpendicular, you do know you have a rhombus. All 4 sides are congruent. See that? So if you know that you have a rhombus, one of the character traits of a rhombus is its diagonals are always perpendicular. So now I do know the diagonals are perpendicular. So anytime a quadrilateral has perpendicular diagonals, the formula is 1/2 times the two diagonals. So the length of one diagonal is 10, 5 plus 5. The length of the other diagonal is 8, 4 plus 4, which would give you a final answer of 40 square units. Alright, number 8. Alright, number 8, we know it's a kite. Okay, we know that because it's a quadrilateral in which these two adjacent sides are congruent, and these two adjacent sides here are congruent, yet all 4 sides are not congruent. So anytime you have a kite, your diagonals will always be perpendicular. Always. So anytime you have a quadrilateral with perpendicular diagonals, you use this formula right here. Alright? So one diagonal is going to be 12, 2 plus 10, and the other diagonal is going to be 12, 2 plus 10. So your answer is going to be 72, 1/2 times 12 times 12, 72 square units. Alright? Moving on to numbers 9 through 12, the directions say to find the area of the quadrilateral. Okay? Now, I think it's pretty obvious. The first thing you always have to do is identify what kind of figure you have, what kind of shape that you have. This is a parallel. This is a trapezoid because we have a quadrilateral which exactly 2 sides are parallel. So anytime you're given a trapezoid, in order to find the area, you want to take 1/2 times the height times the 2 bases added together. Okay, well, I'm going to go ahead and put 6 for my height because that's the line that connects the 2 parallel. That's the line that's perpendicular to the 2 parallel sides. So my height is 6. And I'm going to add the 2 bases in my head. The bases are always the parallel sides, so 8 plus 4 is 12. So your answer would be 36 square units. Okay, 36 square units. Number 10 is also a parallel. It's also a trapezoid. Excuse me. Okay. Now, if it helps you to learn to take these things and turn them, then do that. Okay. Now a lot of you probably don't need to do that, and that's fine. Some of you do, and that's fine. Okay. Nothing wrong with doing that if you need to. So let's turn this thing so that our bases, our parallel sides, are running horizontally. So this side here is 16 because of this number here. This side here is 8 because of this number here. And then this dotted line is the line that would be like right here. Go over and then come down, and notice it's perpendicular. So this is my height right here. So in order to find the area of this trapezoid, it's 1/2 times the height, which is 14, times the bases added together. Well, I'm going to do that in my head. I'm going to get 24. Alright? And then, what would that be real quick here? Let's see. 148. I believe I did it quickly in my head. If I'm wrong, I'm wrong. Let's see if that's right. 168. 7. Yeah, that's right. 168. So the answer is 168 square units. Alright? Moving on to number 11. Now in number 11, we see right away we have a rhombus because all 4 sides are congruent. So we know immediately our 2 diagonals are perpendicular. So in order to find the area of this rhombus, I have 1/2 times my 2 diagonals. One diagonal is 10, 5 plus 5. The other diagonal is 14. 7 plus 7. 1 half times 10 times 14 would be 70 square units. And by the way, if you notice something about all of your rhombi so far, the diagonals are not only perpendicular, they also bisect each other. And of course that's true with all parallelograms. We learned that a long time ago, that the diagonals of a parallelogram bisect each other, and a rhombus is a parallelogram, okay? Alright, moving on. Number 12. I know that I have a kite because these two adjacent sides are congruent, and these two adjacent sides here are congruent here, and all four sides are not congruent. So if I have a kite, then I know that I have perpendicular diagonals. So how do you find the area of any quadrilateral that's perpendicular diagonals? 1 half times d times d. So one diagonal is 4, 2 plus 2. The other diagonal is 8, 3 plus 5. So 1 half times 4 times 8 would be 16. 16 square units. Alright, moving on to numbers 13 through 16. They want us to find the value of x when you are given an area of 48 square units. So the next four problems all have the same area. The area equals 48 square units. Okay, so now they're giving us the area, and they want us to find the missing variable x. Okay, so first of all, let's identify the shape we're dealing with. It is a trapezoid. So I know my formula is 1 half times the height times the two bases added together. Okay, now obviously my height is 6. Okay, and one of my bases is 10. So I'm looking for the other base. Okay, so I'm going to say my area equals this. So for area right here, I'm going to substitute 48. Let's stop and review. This is my formula in order to find the area of a trapezoid. Okay, so I made it. Usually you're solving for A. Usually you put numbers in for H, B, and B, and you solve for A, but now we're doing it a little different. Okay, now things are being done a little differently. I'm going to put a number in for A, and for H, and for one of my B's, but now I'm missing a B. I've got to solve for this B right here. Okay, so here's my suggestion. First of all, I would simplify real quick, and I would write this. I would write 1 half times 6 is 3. So now you have 3 times 10 plus B. That's pretty simple. Now take your 3 and multiply it through. 3 times 10 is 30. Plus B would be 3B. 3 times 10, 3 times B. Bring the 30 over, make it a negative 30. So you're left with 18 equals 3B. Now divide both sides by 3, and 6 equals B. And let's see if that's right. Put a 6 right here, real quick. 6 plus 10 is 16. 16 times 6 would be 96. Divide that in half and you get 48, which is what you want to get. So yes, x equals 6 units. Alright, number 14. Now number 14 is again a trapezoid. So we're going to use the exact same formula. The area, of course, stays the same. So there's your area. The formula is going to stay the same because we're still dealing with a trapezoid. So it's 1 half times the height times the two bases being added together. Alright, so for A, I'm going to substitute 48. For 1 half, I'm going to substitute, 1 half. For H, I'm going to put my x. Okay, that's my unknown right there. Alright, and then for my two bases, I have 14 plus 10. 14 and 10. So I'm going to go ahead and put 24. Okay, now we have all these multiplying together. You know, when you're multiplying, it doesn't matter what order you go in. 1 half times x times 24 is the same thing as 1 half times 24 times x. 1 half times 24 is 12, and 12 times x is 12x. Now divide both sides by 12, and you will get 4 for x. 4 equals x. Alright, so not too difficult as long as you're using the formulas. Alright, number 15, we have a kite. Okay, excuse me, we do not have a kite, I apologize. We have a quadrilateral in which the two diagonals are perpendicular. So we know right away the formula that we're going to use is going to be area equals times x is 4x. Now divide both sides by 4, and 12 equals x. Okay, so that diagonal has a length of 12. Alright, number 16. Once again, the area is going to be 48. I have a rhombus. I have all four sides that are congruent. Okay, all four sides are congruent. So very quickly, I'm just going to say 1/2. Area equals 1/2 times diagonal times diagonal. So for the area, I'm going to put 48. For 1/2, I'm going to put 1/2. For the one diagonal, I'm going to put 12. Okay, 6 plus 6. And for the other diagonal, I'm going to put, well, now be very careful here, students, okay? Because this x is not the diagonal. Now I'm going to tell you, I didn't catch that right away. I'm going to tell you something. The only way I know of to find this length of x is to find this diagonal. Then I'll know how long this side is here. Then I'll know how long this length here is. We have a right triangle. We can then use Pythagorean Theorem to find this leftover side right here. So we got our work cut out for us, okay? So one diagonal is 12. Let's call this other diagonal y, okay? So I'm solving for y. So 48 equals 1/2 times 12 is 6. So 6y divided by 6, 8 equals y. So I just found the length of y. Okay, y is 8. So what that means, students, is this whole length right here is 8. So if the whole length is 8, then half of it is 4. So I know the diagonal is cut up into segments of 4 and 4. Now, I have a right triangle right here. I know it's a right triangle because my diagonals are perpendicular. This is a right angle. This is a leg. This is a leg. I'm looking for the hypotenuse. So leg squared plus leg squared equals hypotenuse squared. 4 times 4 is 16. 6 times 6 is 36. 36 plus 16 is 52. Take the square root of both sides. The square root of 52 would be 7.2. So one answer would be 7.2, which is totally acceptable. Or if you want to break down the square root of 52, that would be, wow, what would that be? 4 times 13. So 52 is the same thing as 4 times 13. 13 times 4. We know the square root of 4. Take the square root of 4 and put a 2 on the outside. So 2 square root of 13. Okay, so either one of these two answers right here would be acceptable. Alright, either one of those. Alright, moving on now to numbers 17 and 18, 2-word problems, okay? And they want us to find the area of each section of the frame. Now, let's talk about that. The very last sentence says, find the area of each section. That means they want you to find the area of this trapezoid. And that is a trapezoid, okay? Look at it carefully, look. That's a trapezoid, okay? Of course, if we find the area of the top one, that'd be the same thing as the one down here, okay? And then we also have to find the area of this trapezoid here on the side. Now, this is decently easy, but you're still going to have to do some thinking on this. So take really good notes and pay attention. The picture frame has outer dimensions of 12 by 14. Outer means this by this. Okay, let's label that real quick, shall we? Here we go. This looks longer, so I'm going to call this 14, and I'm going to call this 12. Now the inner dimensions, this and this, are 8 by 10. Now, maybe I'm wrong, but this looks longer right here, so I'm going to call this my 10, and this my 8. Now, watch this carefully. What I do, I'm going to kind of bisect this thing down, okay? Or dissect it down, excuse me. Now, here's my trapezoid right here. I'm going to pull it off to the side, okay? So there it is. Make it a little bigger so we can write on it if we need to. Alright, so we know this length going across is 14. We know this length going across here is 10. Alright, we we are going to assume we have to have an isosceles trapezoid. We're going to make that assumption because, I mean, these lengths here all have to be the same, or the picture frame would be kind of cockeyed. It wouldn't even look right. Okay, so if it's a well-made picture frame, then we're going to have isosceles trapezoids. So what I have to find would be the height right here. Okay, and then I can find the area. Well, guys, think about it. If from here to here is 10, that means from here to here is also 10. So that means this little length right here has to be 2, and this little length right here has to be 2 to give you a total of 14. Alright, so I'm just saying we do have some, we're not going to use that information, but I'm just trying to show you that we do have isosceles trapezoids, so there's some things that we can figure out about this. Now, look at this right here. If I were to draw this line straight up here, okay, and draw this line straight up here. Watch this, please, students, so carefully. Are you ready for this? The length from here to here, like I just showed you down here, is going to be 2. Do you see that? And the length from here to here is going to be 2. I just showed that to you down here, okay? So, are you ready for this? Watch this so carefully. If this length right here is 2, then that means this length right here is also going to be what? 2. Don't forget that, because you just found the height of this trapezoid right over here. Look at this trapezoid in red right here. Watch this. See this trapezoid right here? Okay, you know the base of it's 12. So we know this length over here is 12. We know this base is 8. We just found the height. The height of that trapezoid is 12. Okay, I'm going to go ahead and draw that off to the side right here. This is 12. This is 8. And this height right here is 2. Now, watch this very carefully, please, students. I'm going to make all of those same assumptions with my other trapezoid. Watch this carefully, please. Now, watch this. If I'm going to put this 8 over here. Now, if this is 8 from here to here, and this is 12 from here to here, then bring your 8 up. That means from here to here is 8. This line right here has to be 8, just like this line right here is 8, okay? Which means then, if the whole thing's 12, that means this little bit here has to be 2, and this little bit has to be 2. So now think about it, guys. If this line here is 2, that means this line right here is also what? 2. So you just found the height of this trapezoid right here. You just found the height of it. So this dotted line here is 2. So we can find the area of this green trapezoid pretty quickly. It's 1/2 times the height, which is 2, times your two bases add together, which is 24, which would be 1/2 times 2 times 24 is 24 square units, okay? So that's going to be one of your answers. Two of them are 24 square inches, this one and this one. Now, the other one right here, let's grab this, make a little room here. If I can get this thing to work here. Alright. We'll bring that 8 over in a second. Now flip this thing around. There we go. So now to find this area, I would have 1/2 times the height times my two bases add together. 8 plus 12 is 20. And you would get 20 square units if you multiply those three numbers together. So the other two are 20 square inches. I guess it'd be inches because it was given to us in inches. So instead of saying units, I should say inches. Alright, so there we go, not too difficult. Okay, you are fertilizing your lawn, shown below. One bag of fertilizer will cover 3,500 square feet of lawn. How many bags do you need for your lawn? Well, students, there's many ways to do this, okay? You could divide this up into a trapezoid here, and then a trapezoid here, then one here. But I'm telling you, the best way to do this is simply notice you have one big trapezoid. So just simply find the area of that entire trapezoid, then find the area of this white rectangle and subtract it out, then find the area of this white rectangle and subtract it out, and you are finished. That's the best way to do this, okay? So let's first of all find the area of this entire green trapezoid, this whole thing, even the white part, this whole trapezoid, this whole thing, okay? Well, the formula for area of a trapezoid is 1/2 times the height. Well, the height would be 89 times the two bases being added together. So one base is 169 and the other base is 67. So we add those two together and we get 236. Alright, so now we're going to take 1/2 times 89 times 236, and we're going to get 1,502. So put that over here. 10,502. 10,502 would be the area of the entire green trapezoid. Now, let's subtract out this white rectangle. Well, that's easy enough. It has a length and a width of 25 and 51. So very quickly, 25 times 51 is 1,275. So minus 1,275. And then we can very quickly find the area of this little rectangle here. Okay? It's going to be 10 feet across and 25 feet long. So it has a length and a width of 25 by 10. That's 250. So minus 250. So 1,502 minus, 10,502 minus 1,275 minus 250 is going to give you 8,977. So you just found the area of the entire lawn on your property. Now, students, one bag is 3,500 square feet. One bag. Well, if you buy 2 bags, that's only going to cover 7,000 square feet. If you buy 3 bags, that's going to cover 10,500 square feet. So unfortunately, you're going to have some leftover fertilizer, okay? I wish you could go in and you could buy, 2.5 bags, but you can't. So you're going to have to buy 3 bags of fertilizer, all right? Okay, moving on to numbers 19 through 22. Actually, 19 through, I believe, let's see here, 19. Yes, numbers 19 through 22, the directions say to find the area. So here we go, let's see how we do on these, okay? Let's find the area of, first of all, this trapezoid, okay? Now, I do have a trapezoid, by the way, and I know that because, now listen, students, you can't just make assumptions. You gotta know why. This is a trapezoid because I have 2 lines that are perpendicular to the same line, and we've learned that whenever 2 lines are perpendicular to the same line, those 2 lines are parallel. So I have this line here parallel to this line here, okay? And I know this line here is not parallel to this line here because I don't have a right angle right here. So we are good. Alright, now, here we go. In order to find the area of a trapezoid, it's 1/2 times the height, which would be 12, times the 2 bases added together, 9 plus 16, 25. Alright, so 1/2 times 12 times 25 would be 150 square units. Okay, so the area of this trapezoid is 150 square units. Alright, number 20. Now we do know that we have a kite, okay? We know this because, we have these 2 sides here, these 2 adjacent sides are congruent, these 2 adjacent sides are congruent, and all 4 sides are not congruent. So because we have a kite, we know that we have perpendicular diagonals, and because we have perpendicular diagonals, I know I can use this formula here. The problem is I don't know the length of both diagonals. I know one diagonal is 20, 12 plus 8, but the other diagonal, I just don't know. Okay, question mark. I'm not sure. So I have to find this length here. Well, students, look, I can do this pretty easily. Isn't this 13? Sure it is. Isn't this a 12 right here? I've got a right triangle, guys. I can find that missing leg so quickly. Now, we've done so many Pythagorean theorem problems this year, students. I really don't want to work these out. They do take a lot of time, so I'm going to simply say to you, you have a right triangle right here, and you know a hypotenuse. You have a leg. You're missing a leg right here, okay? So with that in mind, I'm going to very quickly whip through Pythagorean's theorem. 12 squared plus x squared equals 13 squared, okay? 13 is your hypotenuse, so you really have 169 minus 144, which gives you 25. So you have x squared equals 25. Square root of both sides, you get 5. So this length right here is going to be 5, okay? Now, think about this for a second, students. If this is a 13 here, okay, then that means this has to be a 13 right here too, correct? Sure it does, definitely. Okay, so I have another right triangle right here with sides of 13 and 12, so this leg has to be the same. It has to be. I mean, I could do the exact same formula again using Pythagorean's theorem if you guys want me to, and you'd still get 5 right here. So your other diagonal is 10. So the answer is 100. 1 half times 20 times 10, 100 square units. Number 21. Alright, now, first of all, let's see what we have here. Okay, I know these two lines here are parallel. Well, first of all, hold on. I have a quadrilateral, okay? And I know I have all 4 angles are 90. How do I know that? Well, because 90 plus 90 plus 90 is 270, and a quadrilateral always has a sum of 360 degrees of its interior angles, so the leftover angle has to be 90, okay? So really, students, I mean, I either have a square or a rectangle, correct? So I know if this side here is 16, I know this side is 16, I know whatever this side here is will be the same as this side over here, and I've got a right triangle. I mean, look, right here's my right triangle. So I'm missing a leg. I know the hypotenuse, I know a leg, I'm missing a leg right here, okay? So I'm going to do it very quickly. Like I've said, we've done a lot of these. It would be 16 squared plus your other leg squared equals your hypotenuse squared. So that's basically 400 minus 16 squared. That would be 144. You'd end up with 12. Okay, so this, if you did Pythagorean theorem on this, you would have L squared equals 144, which would then give you 12. So how do you find the area of this? Well, it's a rectangle. 12 by 16, okay? So 12 times 16 would give you 192 square units, alright? Moving on to number 20. Well, guys, look, I mean, this is really simple. If this is 90, first of all 4 sides are congruent. I know I have a rhombus or a square, which means I have a what? Parallelogram, right? Come on, guys, think about it. A square and a rhombus are both parallelograms. So I know I have either a square or a rhombus because all 4 sides are congruent. Well, I know that I have a rhombus for sure. And it might be a square. It might be a square rhombus, okay? So I know this is 90, and parallelograms, opposite angles are congruent. Okay, this is going to be 90 also. Well, in a parallelogram, consecutive angles are supplementaries. This is 90, and this is 90. I've got a square. I've got 4 right angles and 4 congruent sides. So remember, anytime you have a square, that means your 2 diagonals are congruent. So if this diagonal is 20, then this diagonal is also going to be 20. And also in a square, your diagonals are perpendicular. So I have 1 half times diagonal. Listen, students, anytime your two diagonals are perpendicular and your figure is a quadrilateral, you multiply the two diagonals together and multiply by 1/2. If you do that correctly, you will come up with 200 square units. Alright? Okay, moving on to numbers 25 and 26. A cross section has a height of 2 and bases of 10 and 12. What is the area of the cross section? Okay, now I left this up here so you can see what the cross section looked like. There's a cross section, okay? It's a trapezoid is what it is, guys, okay? In fact, if you look at the instructions say that gold bullion is made into blocks with cross sections that are isosceles trapezoids. So I know that I have an isosceles trapezoid, okay? There it is. And I know my two bases are 10 and 12. What is the area? Well, guys, you know to find the area of a trapezoid, it's 1/2 times the height times the bases added together. We know the two bases are going to give us 22 when you add them together. The only thing I'm missing is the height. Here's the height right here. Okay? So that's the only thing that we're missing. Alright? So, let's see if we can't figure this out. Okay, students, I'm back. Sorry about that. I totally messed up. They do give us the height. I didn't think they did. So I was trying to draw right triangles and use sine, cosine, and tangent, whatever. They do give us the height right here. The height is 2. So this is pretty simple, actually. The area would be 22. 1/2 times 2 times 11 is 22 square centimeters. Okay, pretty simple. Now, let's continue on. Now they ask us to find the lengths of the diagonals. Okay. Of the cross section. Well, look, guys, if you truly have, let me see if I can get this erased here without erasing everything else. If you have an isosceles trapezoid, which you do, these diagonals have to be congruent. Okay? They have to be, because you would have two congruent triangles. If I were to draw this triangle here, I'm highlighting in red, okay? And then draw this diagonal here. I don't want to get into proving that, but actually it'd be pretty simple. If it's an isosceles, you know this green side is going to be congruent to this red side over here. And they share this side here. And then this angle right here, this whole angle right here, would be congruent to this whole angle. We should very easily be able to prove the two triangles are congruent. So what I'm saying to you is this: the two diagonals are congruent. So when they ask us to find the lengths of the diagonals, we can really just find one, and that's the same as the other. Well, if you want to find both, you can, but you will get the same answer. So here's the diagonal I'm going to find the length of right there. Okay? Now, that looks like it's pretty challenging. How in the world do you do that? But if you remember, we have a height right here of 2, and we have a right angle. So what I have now is a really nice right triangle. Okay? See that? So you say, well, Mr. Earhart, this length of 12 goes from here all the way to here. You're right, it does. So what's the length of this from here to here? Well, it's actually going to be, well, let's see if we can figure it out real quick, okay? If this, okay, look at it like this, guys. Let me use green here to help you. If this length from here to here is 10, then the length from here to here is also 10, okay? Now, if the whole length is 12, that means this little section right here has to be 1, and this little section right here has to be 1, okay? So, now watch this, please, students. This section I'm looking for runs from here all the way to here, so it's the whole thing is 12 minus 1. This whole length here is going to be 11. Now, Mr. Earhart, you made one assumption I don't think you can make, and that assumption is that this section from here to here is congruent to this. Well, I can definitely make that assumption, because if I were to draw a height right here, this side here has to be congruent to this side here. So I can definitely say that this segment here from here to here is the same as this here. So if the whole thing's 12 and this much is 10 from here to here, this has to be 1 and this has to be 1, okay? So with all of that in mind, then all I have to realize is this. The entire section is 12. Take out this one piece right here, and now you know this length here is 11 from here to here. So I can find the diagonal is my hypotenuse. So Pythagorean theorem real quick. 2 squared plus 11 squared equals hypotenuse squared. So grab my calculator very, very quickly here. We would have 4 plus 121. Square root of that would be 22. You end up with 484. 484 equals hypotenuse squared. Take the square root of both sides, and we come up with 22. Now, for the other part of this problem, would the area equal half the product of these lengths? No, because the two diagonals are not congruent. Okay, the two diagonals are not the two diagonals are not perpendicular. There's not a right angle there. Okay, so no, you could not find the area by taking 1/2 times the product of the lengths. No, that would not work. Okay. Alright, moving on to our last D, 29 through 31. And here we go. First of all, find the area of number 29. Now, this looks like a kite to me, but I'm not for sure. So what I'm going to very quickly do is find the slopes of these two diagonals. Got it? And remember, if they are opposite reciprocals, then they are perpendicular. Okay, so let's find the slope of these two lines real quick here. My rise from here to here, my rise would be 1, 2, 3, 4, 5, 6. So my rise is 6, and my run would be 1, 2, 3, 4, 5, 6. So it goes up from left to right, 6 over 6. So this line here has a slope of positive 1. Alright, now let's find the slope of the other diagonal. Alright, well, let's find the rise from this point going up to this point. It would be 1, 2, 3, 4, 5. Okay, so from here to here would be 5. Now the run would be 1, 2, 3, 4, 5. So we get 5 over 5. The only thing is, the line runs from left to right downward, so the slope would be a -1. But I might be confusing some of the students who've only had algebra 1 so far. Let's go back to our good old y minus y over x minus x. If I'm confusing you with the rise over run, this ordered pair here is 2, 8. This ordered pair here is 7, 3. Okay, so y minus y is 8 minus 3. X minus x is 2 minus 7. You would get a positive 5 over a negative 5, which would give you a -1. So the slope of this diagonal here is -1. Now, are they opposites? Yes, they have different signs. Are they reciprocals? Yes. If you take 1 and flip it, you get 1. So these two lines are perpendicular. Okay, they are perpendicular. So now what we have to do is very quickly find the length of those two diagonals and multiply them together. Okay, so a lot of work on these, but it's good for you. So here we go. Let's go ahead and draw this diagonal here, even though it's not a very clean drawing there, and we're going to call that point 0, 1. Okay, this point here would be 6, 7. Let's find the length of that diagonal. Of course, we know how to do that distance formula. X minus x, 0 minus 6 quantity squared, plus y minus y, 1 minus 7 quantity squared. We'd get 36 plus 36. So the square root of 72. Alright, so the length of this green line here is the square root of 72. That's one diagonal. Now let's find the length of the other diagonal. So here it is right here. And of course, like I had before, this is 7, 3 for the ordered pair, and this ordered pair here is 2, 8. So using our distance formula, X minus x would be 2 minus 7 quantity squared plus y minus y would be 8 minus 3 quantity squared. So we would have 25 plus 25, which would be the square root of 50. Alright, so there's my two diagonals. So in order to find the area of this kite, I would have 1/2 times the square root of 72 times the square root of 50. So that's a big calculator problem there. If you take the square root of 72 times the square root of 50 and divide that by, or multiply it by 1/2, you get exactly 30. You get 1/2 times 60, which would give you 30 square units. Okay, so not too bad. Number 30. Now I could be wrong, but this really looks like we have perpendicular diagonals again. It really does. So I'm going to very quickly find the slope of these two diagonals and see if they're perpendicular. This point here is 2, 8. This point here is 6, 5. This point here is 6, 0, and this point here is 0, 2. Alright, let's find the slope of this line right here first, okay? So y minus y is 2 minus 5, x minus x is 0 minus 6, negative 3 over negative 6, that's a positive 1/2. So this line right here has a slope of 1/2, okay? Now, let's find the slope of this line right here, okay? So, y minus y, 8 minus 0, 2 minus 6, x minus x, that would be 8 over negative 4, which would give us a negative 2. So this line right here has a slope of negative 2. Now, are they opposite? Yes, their signs are different. Are they reciprocal? Yes. If you flip 2 over 1, you get 2. So those two lines are completely and totally perpendicular. So if two diagonals are perpendicular, how do you find their area? Well, remember, 1/2 times diagonal times diagonal. So here we go. Use the distance formula. Let's find the distance of this diagonal right here first, okay? So here we go. X minus x, 0 minus 6 squared plus y minus y, 2 minus 5 quantity squared. That would be 36 plus 9, so the square root of 45. So that would be the length of one diagonal. So I have 1/2 times the square root of 45. Now the other diagonal, this one right here, let's find its length, okay? So distance formula again, x minus x, 2 minus 6 quantity squared, plus y minus y, 8 minus 0 quantity squared. So we end up with 16 plus 36, which would be the square root of 52. So the other diagonal is the square root of 52. Let's multiply these two together and see what we come up with. Square root of 45 times the square root of 52 equals, that gives us 48. Now I might have made a mistake on this one. I'm getting something a little different here. Let me check my work real quick here. Okay, students, I'm back. If I was in class there with you, you would have probably saw this mistake and called it out to me. 8 minus 0 is 8. When you square that, you'll get 64, actually. Okay, so 8 minus 0 is 8. 8 squared is 64. This would give you the square root of 80. Alright, so this should be the square root of 80. I hope that takes care of it. Let's see. Here we go. Yes, that takes care of it. When you take the square root of 45 times the square root of 80, you get 60. 1/2 times 60 is 30. 30 square units. Alright, and there it is, okay? Alright, moving on to our last problem. Now, when I look at this, I'm guessing, okay, that these two sides here are parallel, which would give me a trapezoid. Okay, students, so I've got to make sure they're parallel. If they're parallel, they'll have the same slope, okay? So this ordered pair right here is 1, 8. This ordered pair right down here is 2, 0. Okay? This ordered pair here is 8, 1. And this ordered pair here is 7, 5. Now, let's let's find the slope of this line right here very quickly, okay? So y minus y, 8 minus 0, x minus x, 1 minus 2. That's 8 over negative 1, negative 8. So the slope of this line here is negative 8. Now let's find the slope of this line right here. Same way, okay? Y minus y, 5 minus 1. Did I make another mistake again, guys? Let's see here. No, I did not. So it looks like these two sides here are not parallel. Let's see. This would be, yep, they're not parallel. So 5 over 1, y minus y is 5 over 1, x minus x is 7 minus 8. Your slope would be 4 over negative 1, negative 4. Alright, so these two lines are not parallel like I thought they were because they do not have the same slope. So totally my fault, but that's not going to work. So I'm going to try something else. Maybe, just maybe, the diagonals are perpendicular like the other two problems. So let's check and see if they are. Okay, students, I did pause the video and check, so I would not do it wrong and have to waste more of your time. And it ends up that these two diagonals are perpendicular. But I'm going to go ahead and prove that to you so you're not just taking my word for it, okay? So these two diagonals are perpendicular. They're going to have opposite reciprocal slopes. Watch carefully, okay? I'm going to find the slope of this diagonal first. So y minus y, 0 minus 5, x minus x, 2 minus 7. That would give you negative 5 over negative 5, which would give you a positive 1. Okay, so the slope of this line right here is m equals 1. Alright, now let's find the slope of this diagonal right here. Alright, so we have y minus y, 8 minus 1, x minus x, 1 minus 8. That gives you 7 over negative 7, which is negative 1. So the slope of this line here is negative 1. So are they opposite? Do they have different signs? Yes. Are they reciprocals of each other? Yes, they are. If you flip 1, you get 1. So I have perpendicular diagonals. The two slopes are opposite reciprocals. Thus, I can use this formula right here. Anytime a quadrilateral has perpendicular diagonals, you can multiply them together and then multiply by 1/2 to get the area. So let's find the length of this diagonal here. So using the distance formula, I would have x minus x, 2 minus 7 quantity squared, plus y minus y, 0 minus 5 quantity squared, which would give me 5 squared 25, 5 squared 25, so the square root of 50. So one diagonal is the square root of 50. Now the other diagonal, this one right here, let's see what his length is. Okay, here we go. X minus x, that's 1 minus 8 quantity squared, plus y minus y, 8 minus 1 quantity squared. So that would be 7 squared, 49. This would be 7 squared, that's 49. That's the square root of 98. Unless I made another mistake, which I hope that I have not. Alright, let me grab my calculator real quick. The square root of 50 times the square root of 98 is 70. So the area is 1/2 times 70, which would give you 35 square units. 35 square units. Okay, these are really good problems, guys. I hope that you've learned a lot from this. If you have any questions, don't hesitate to call or email.